This demonstration illustrates the advantages of using microtesters in your engineering characterization lab and for high-volume production on your test floors. By using the same measurement instrument at both locations, test correlation issues are either minimized or eliminated completely. For this demonstration, we will be using the SP8V microtester to test a high-precision DAC. Using microtesters in production test allows our customers to reduce the cost of test by transferring high-performance devices to lower-cost testers. We configured the form factor of this microvoltmeter to plug directly into the tester load board. SP8V is an 8-channel credit card-sized microvoltmeter manufactured by Microtesters. Today, we will use the SP8V to measure the performance of an analog device's AD5791. AD5791 is a 20-bit SAR DAC. It's one of the highest performance DACs on the market. In this demonstration, we will measure the first 256 codes in the DAC's output voltage transfer function. We will be testing for missing codes, DNL, and INL. Let's run the test. These are the measurements that we collected. If we zoom in on the graph, we can see the deviations of measured results against the ideal line. The red line represents the transfer function of a perfect device. The white dots are the actual measurement of each code. You can see the actual step errors in microvolts above and below the line. Now, let's zoom back out to display the entire test. To visualize the errors associated with the transfer function of the DAC, we can go to the differential nonlinearity display on the DNL tab. This display normalizes the measured value of each DAC code to the ideal predicted value. The results are displayed in DAC LSBs. A value of 0 means that the measurement was equal to the predicted value. A value of 1 means that the measured voltage was off by one whole LSB. The LSB size for this device is 19 microvolts, so the maximum error was about 7.2 microvolts. The full-scale values for the window are plus and minus 0.4 LSBs, or about 15 microvolts in total. The microtester collects all measurement results. It also calculates the INL, DNL, best fit line, and the deltas for each point from that line. Since all of these calculations are done in the background by the microtester, there is no test penalty. We can also see the integral nonlinearity results by selecting the INL tab. INL errors are the value of each code measurement relative to the predicted ideal line. The ideal line was created by applying a simple best linear fit algorithm to the captured data points. The maximum INL error is approximately 0.279 LSBs, or about 6 microvolts, at location 140. The full-scale value of this window is 0.3 LSBs, or about 12 microvolts in total. The LSB size is calculated using two techniques: average step size and endpoints divided by the number of steps. We can see that both techniques produce an LSB size of 19.07 microvolts. The next part of the demo shows the guard band needed for the SP8V as compared to the guard band needed for a typical high-performance test system. The example measurements are for a series of devices. The measurement is a static VOH test. The SP8V requires less margin than a typical PMU because of its increased accuracy. That's represented by the yellow line. With the PMU guard band set to 1.8 volts, the lot yield was 56.6%. The SP8V can use a lower guard band set here at 1.79 volts. The lot yield was a higher 86.3%. The red dots represent devices that failed using both devices. The yellow dots represent devices that passed with SP8V but failed using the PMU. The green dots are devices that passed using both instruments. The MCX platform is one of our newer configurations. In this case, a 4-channel instrument. It's made up of 4 single-channel instruments in a portable package. We can also configure the microtesters to mount on a larger board that would fit into your test system or instrument rack. Either way, Microtesters brings microvolt accuracy to your production test floor. Thank you very much for listening, and please check out our website, www.microtesters.com.